Again, welcome to Introduction to Data Science, lecture number 1. So in these lectures, I'm going to discuss about what is data science, where do we see data science, also the steps in doing data science, and the last will be the skills needed to do data science. So here we have the definition of a data science. Here we say a data science is a field of study and practice that involve the collection, storage, and processing of data in order to derive important insights into a problem or phenomena. So here from the definition, we can see that the concept of data science is almost the same as statistics or data mining. Now, the difference between data science and statistics is that data science normally involve in a large volume of data. And sometimes also the data may be different structures of different formats. So we need additional skills how to prepare the data, which we normally call the data preparation phase. Example will be normalizing the data or transforming the data types. So the concept of statistics, we will see it in data science also, but in data science it will again be a little bit more advanced, since data science deals with huge volume of data comparing to statistics, where normally we deal with a very small number of data, setting hypotheses, finding the inferential or descriptive statistics, summarizing. In data science, normally we don't set hypotheses. We have a data set, we want to find the format. We want to find the patterns in the data or similarities in the data or predicting something from the data. So there's no any hypothesis here. Even first, before we start the process, we don't even know the result. So that's the main difference. Now, in terms of the discipline of data science, we say data science is an interdisciplinary field. Interdisciplinary field is involving processing and also system to extract knowledge or insight from data in various forms. Now, the data can be either structured or unstructured data. In the coming videos, we are going to discuss about different data. We may talk about what is a data structure, what is unstructured data. A very simple example of a structured data would be a data from our database system, like relational database system, let's say Microsoft Access or Oracle. A relational database system, normally the data is organized in the columns and rows. The columns is normally called the field. The rows, again, normally we use the term the records. This is a structured data. Unstructured data can be, example, data from our web pages, test data. So again, we may discuss that in the future lectures. So here we say data science also is an interdisciplinary field about processing and also system to extract knowledge or insight from data in the various forms. The data can be again structured or unstructured, which is the continuation of some of the data analysis fields, such as again statistics, data mining, and also predictive analysis. Also, the term data, I decided to use the term here, the term data science, according to Harvard Business Journal, is the sexiest job of the 21st century. And we all know data science, scientists are highly well-demanding field now. So what is the steps in doing data science? Here we can see a data science play the most active roles in these 4 A's of data. First is data architecture, then data acquisition, data analysis, and also data archiving. So again, we know that data science is much more than simply analyzing data. And there are many people who enjoy analyzing data and who could happily spend all day looking at, example, would be histogram or different types of charts, or finding the average, mean, median, etc. But for those who prefer other activities, data science also offers a range of roles, and it also requires a range of skills. Some of these skills will be, we should have the concept of data architecture, which is how data will be routed and also organized to support analysis, visualization, and also presentation. This is supposed to be presentation. And then data acquisition is how data are collected and also presented before analysis process. So in data acquisition, we are going to use different techniques to, again, collect our data and also prepare the data. Example would be data preparation, as we said earlier. Then after we prepare our data finish, we are going to analyze our data. So the next step is data analysis. This is where we do the summarization, preparation of the data, and also apply the algorithm to run the data. So after we finish everything, the last step will be data archiving. Data scientists always, one of the major goals is to preserve the data. Most of the time we have a lot of secondary data online that we can use for project or research. So preservation of collected data in a form that make it reusable is one of the main steps in data science also. So this is an example of the reason why we say data science, data miners, even pattern recognition, predictive analysis, etc. It's a very highly demanding field because now we can see in our society, we are living in a data-driven age now, data-driven age. Most tasks that we perform today always generated data. If we quite remember a few years back in a medical field, we don't do much data analysis. But today, we even have the field of bioinformatics, which is analyzing the data, biological data, to maybe predict or even to give a diagnostic, etc. So today, most tasks we perform is always generate data. So we can see here we have exponential graph from 2010, and we are projecting up to 2025. We can see the range of our data that, again, we are going to accumulate. So it's more or less, again, exponential increment. So we have something called the 3V model of data. The 3V here, we want to talk about big data analysis. This is where data science also is involved. As we mentioned earlier, anytime we are doing data analysis, and we are going to use a very large data, this is where the data science techniques comes in. If it's a very small data, we can use the concept of statistics, inferential statistics, or descriptive or visualization to analyze our data. So what is a 3V model of data? First, the velocity. When we say velocity, that's the speed in which data is generated or accumulated. The speed is very high. So here we say speed in which data is accumulated increase. So how data is generated is example would be the data streaming. Example is a camera generating data, video, etc. Also, volume is very important. The size of the data is very large. It's increasing also. Then also data may come from different sources. So variety of the data, different formatting. So here we say we have structured and unstructured data. We may also discuss about the big data analysis. In that section, we're going to discuss about this 3Vs model of data: velocity, volume, and also variety. So here we say data science applications happens or is in different domain. It happens in many field of studies domain. So example will be finance. Finance, we can apply data science techniques. For example, predicting the stock market or predicting if any customer is going to attract attrition or retention or improve customer service in the banking industry. We can use data to, again, apply. And also public policy. And now our government use a lot of data science techniques to apply many policies, even politicians also the same thing. Here we talk about politics. Healthcare also the same. We generate a lot of data in healthcare, so we can again either to improve the healthcare delivery or to even diagnose a patient or predict what kind of disease a patient may have if is doing some practice, some behavior based on some behavior. Urban planning, education, libraries, and again, the list keep going. Engineering field also. We can see recently we had a Google automated car system. This is again data science concept. Self-driving cars. Even now we have self-driving helicopter, planes, and all this again use data science concept. So relation of data science with other fields. In statistics, we already explained that statistics and data science are very, very much alike, but the difference is data science deal with a large volume of data, so the techniques are a little bit more advanced techniques involved. Statistics normally deal with a very small data. In terms of computer science also highly related with data science. The concept of algorithms, machine learning, artificial intelligence, these are also techniques used in data science. Same concept with engineering, like data architecture. This also engineering concept involves software, hardware engineering concept. Then business analytics also relate to data science. Computational, social science, all this, they have a relationship with data science. So what skill do we need for data science? I think the basic three is given here, but again, we have so many skills that we have to know. So yeah, I think the main thing is that if you have a drive for learning new technology, new knowledge. So here we say the willing to experiment. The willing to experiment is very important. Proficiency in mathematical reasoning, very important, because most of data science use machine learning algorithm, which involve a lot of mathematics. And also data literacy. So we have to know data. So I can say one of the background of in data science is to have a good knowledge in statistics, linear algebra because of matrices, etc. And also computer science programming. So those are the three major skills. Other than that, we can go a little bit detail. Acquiring communication is very important. So communicating with data users. So as a data scientist, you must be able to possess a strong skills for learning the needs and also the preferences of users. Communication skills is very fundamental. Most every field of studies is a knowledge that we have to have. Then another one can be seeing the big picture of a complex system. So yes, algorithm analysis and be able to think more computational, using computational approach to solving problems. Also knowing how the data can be represented. So we have to have the concept of data preparation and representation, how data is collected, etc. Data transformation also is very important. So when data become available for the use of decision makers, data scientists must know how to transform, how to summarize, and how to make inferences from the data. Very important. Visualization is very important. Actually, we have so many software applications that is designed basically for visualization of data. And most major two programming language in data science is the Python and R. Both programs have a package for visualization. So visualization is important. And I think the last thing I'll say, attention to detail, quality. And we have to, again, be more proficient also. So computational thinking means I've mentioned this about one of the skills as a data science you have to know. But when we say computational thinking, we mean thinking like a computer scientist. Normally, a computer scientist, we may follow software engineering and development principles or techniques. Maybe first, if I have a large complex problem, I'll try to decompose, to break down the problem into smaller units. Then I'll try to solve it individually. Then later I'll integrate all the small problems together. Analysis from the beginning is important. What should be the input to the system? What should be the output? Then I may come up with designing the solution. Designing the solution is how I can transform the input to output. So these are all the concepts of computer scientists. So here we say thinking like a computer scientist. Also, computational thinking is using abstraction. So again, computational thinking, here we say thinking like a computer scientist. Also computational thinking is using abstraction and decomposition when attacking a large complex task or designing a large complex system. So the concept here means, as a computer scientist, the best way that normally we approach problem, especially a large complex problem, is to try to analyze the problem and most likely decompose the problem into a smaller unit. Then we solve them individually. Then later we integrate the solutions all together. And this is again an interactive process based on the following 3 stages. Abstraction means we are not going into detail. So we just get the problem formulation, understand the problem. Then from there, we do our automation. Then after automation, we analyze. Normally, analyze means the solution execution, then evaluation. There's a diagram here that really explains. So first, problem formulation, that's the abstract level. How does a MOS Lab work? So this is just an example. So this is where we form our problem. Then from there, we come with the solution expression, and which is the automation. So we design the solution. Here we build a simple model of gravity, design the solution. Then step 3, which is the final step, solution execution and evaluation. So we execute the problem and the solution. Whatever solution result we get, we evaluate it. So here it's like abstraction, automation, and analysis. So this is an example of a data science problem before we end this lecture. So this is a Handson exercise. So let's assume we have a data set of 15 observations, which means we have a data set of 15 people or patients. It can be employees, students, 15 persons. Now we want to find if there's a relationship between the height and the weight of these 15 persons. So our goal here is that we can use any of the algorithm. For example, in this case, it's only 2 attributes. So I may decided to use a linear regression or use the regression method. By visualizing this data, I can use a scatter plot, and I'll see if our line, or in this case, the pattern will be straight, increasing or decreasing. And again, this is just a very simple example of what a data scientist can do with a data. And this is one of the things we are going to learn as the lectures goes on. So I'm going to end here with the first lecture, which is lecture 1, Introduction to Data Science. And the main goal of these lectures is to understand the concept of data science. So we cover what is a data science, what skills a data scientist need, what tasks involved in data science, and also compare data science with other fields of study such as computer science, statistics, analysis, or business, etc. So again, see you in lecture number 2 soon. Thank you.